So, good everyone. Today's topic is the electromagnetic spectrum. So, I'm going to tell you the benefits and disadvantages of electromagnetic substance equipment. So, the first one, I have radio waves. It is used to support radar systems. It is used to send signals to electronic devices. Like now, you have a television. You can watch your television because of the radio waves and everything like that. Your electronic devices too. You have microwave. It's used to support communication. Your phone, your telephones, when you are calling, is something we call microwaves for you to be able to hear from here, and the next person in Abuja or wherever you're talking to is also listening to you. Ultraviolet rays. It is used to stimulate the production of vitamin D. As we all know, in the morning we all like to get the early morning sunshine, and that early morning sunshine is vitamin D, and ultraviolet rays help to produce it faster so that we'll be healthy as we all are right now. It is used to make efficient lighting. In infrared waves, it is used as light vision cameras. We all watch action movies like soldiers. When they are going out for operations in the night, they wear these glasses that make them see. These are infrared waves. And for someone like people that had a fracture and they're healing, it's used for their physiotherapy. It helps them. It produces heat for the reduction of pain. Visible light makes us see images, like the way you and I are seeing each other now. It's visible light. We can see whatever we're looking at. Visible light makes our television, computers, and phone screen work. Basically, you can see whatever is on the TV because of the light that is there. And yeah, there's something we also did in our group for us to be able to see visible light. Now, this is white. It's meant to emit light, like literally, because it's written touchlight, so it's light. So this is a dark screen, and so we'll just put this under so that we'll be able to see what is inside here. Okay, you guys might not be able to see from here, but you can see now. You see me, and you see a picture here. If you come a bit closer, you'll be able to see it. Can you? Yes. Oh, you can see from here. So with the emission of the white lights, you can see what is under the screen. Yes? Yes. So now, as we all know, there's obviously a good side of something and a bad side of something. So my fellow group member here will explain the bad side of this.
Okay, so now we have the electromagnetic spectrum, and the elements of the electromagnetic spectrum, as my friend here said, are radio waves, infrared waves, microwaves, ultraviolet rays, X-rays, gamma rays, and visible light. So now we have the bad aspect of this element. So now we're moving on to microwaves. So microwaves can cause painful burns. Like exposure to it can cause painful burns on the skin, and excessive exposure to microwaves can also cause cancer, so it can be cancerous to the skin. For radio waves can cause radiation sickness, and exposure to it can also lead to mutations in the genes. Now, everyone here can remember the Hiroshima bomb. To make that Hiroshima bomb, radio waves were used. That's why the name radioactivity comes in. So, radio waves caused mutations to the genes of the people living in that Hiroshima place, and that's why till today you still see some students or some children being born with some abnormalities and some sicknesses. So now moving on, we have infrared waves. It can cause damage to the eye and skin, and it can also bring about greenhouse effect. Now, infrared waves can cause eye cataracts. I want eye cataracts. Eye cataracts is a disease that makes the eye to continue deteriorating and then until blindness. And that's why you can see this eye. It's meant to be an eye that is red and has all these black patches on it. So now, moving on. We're moving on to X-rays. So now, X-rays can destroy tissues, and they can also be cancerous, as I said earlier, for microwaves. X-rays, too much exposure to X-rays can cause cancer, and that's why anyone that's going for X-rays, like to check their bones or anything, shouldn't do it so often. If not, that person can be prone to cancer. So, gamma rays. Gamma rays are highly destructive and can be used to make nuclear weapons. I'm sure in that Hiroshima bomb, gamma rays were used because it's very, very explosive. And as you can see here in the sketch of the electromagnetic spectrum, gamma rays has the highest frequency, and that is exactly why it is unstable and can be used to make nuclear weapons. So now, visible light. Visible light can bring about pigmentation and thermal damage, and it can also damage the receptor cells in the eyes. And that is why you are advised to not shine a torchlight directly at your eye, because it can spoil your eyes and it can spoil the receptor cells. So now, last but not the least, ultraviolet rays. It can cause alternation to the immune system and can cause sunburn. And that is why we are advised as human beings to not stand directly under the sun for too long, because the ultraviolet rays can harm you and can also alternate your immune system as well as cause sunburns. Thank you very much.
Good day, everyone. We are Group 4, and our group members are Adedoyin Ige, Alabi Israel, Agbara Joel, Petri Norukwe, Famu Agoshola, and I, Adabaya Michelle. Our group is going to be talking about the electromagnetic spectrum. So, firstly, EM waves are waves that can travel through vacuums. And as most of us know, vacuums are basically space. Just think of it as vacuums that can travel in space.
EM spectrum. The EM spectrum is the arrangement of the EM waves. The EM waves, which don't require a medium of transfer, is the arrangement of them. It can be arranged from the lowest frequency to the highest frequency, or from the highest frequency to the lowest frequency. And the way we arrange it according to the highest frequency to the lowest frequency, and the lowest wavelength to the highest wavelength. So now we're going to explain each of them one by one.
Firstly, you have gamma rays. Gamma rays are rays that have the highest frequency but the lowest wavelength. So gamma rays can be used to treat cancer, but because they have a short wavelength, when you use the gamma rays, they have to be focused directly on the tumor so that they can attack the tumor but not damage the cells. So when gamma rays are used in chemotherapy, especially brain tumors, the cancer patient has to wear a helmet in which the gamma rays are concentrated directly on the tumor in order to protect the brain cells. Nextly, you have X-rays. So X-rays are the type of rays that they can pass through almost anything. So X-rays can pass through human beings. That is why they are used to look at fractures and dental records. So because X-rays and gamma rays both are very dangerous, people that practice the use of X-rays, that is like doctors, they usually sit down behind this protected area in which the patient has to stay in a place where they are exposed to the X-rays, because X-rays can damage your skin and cause cancer. But the person that is always exposed to it, like constantly, has to be protected in order to protect them. So X-rays can also be used in airports when they are concealed containers to see through and see what is inside them, because X-rays can pass through the medium. Nextly, you have ultraviolet rays. Ultraviolet rays are divided into 3 bands based on their increasing energy, that's the frequency. So you have UVA, UVB, and UVC. So UV rays are found in sunlight, and that is the reason why we have the ozone layer, because UV rays are harmful. So the ozone layer is used to filter through the UV rays so that they don't hit us directly. But as we all know, our ozone layer is breaking down, so the chance of someone getting skin cancer from being outside too long has vastly increased. So to protect yourself from UV rays, you're meant to wear things like goggles or sunscreen. So UV rays are very popular in countries with long periods of sun for shorter times. So exposure to UV rays can cause premature aging and skin cancer, as I've mentioned. But UV rays are also used in hospitals like gamma rays and X-rays because they still have benefits.
Now we have visible light. So light is used in our everyday lives to do different things like reading, moving around so we can see. in the dark. And even in our classroom, we have light bulbs, so that's where visible light falls under. And as you can see, we colored it in a way that it shows the primary colors and how they mix to form secondary colors and tertiary colors. Moving on, we have infrared. Infrared is used in sensors. Infrared waves are transmitted. They come out of human body. So infrared sensors that sense motion. When people move and the infrared radiation comes out from them, the infrared sensors sense it, and those can be used in burglar alarms and things like that. Microwaves, as the name implies, microwaves are used in microwave ovens. So they can be used to transfer heat to the food, and the microwaves do not affect the plastic or the ceramic that you put the food in. They only affect the food. So they heat the food. That's why we can get hot food even after we put it in the fridge. And lastly, radio waves. Radio waves can be used in broadcasting. They can also be used in televisions. So since they have the highest wavelength, they can be used to transmit signals over a long distance and a short distance as well. So this is our project on electromagnetic spectrums. What? Oh, okay. So the wavelength of gamma rays, since it is lowest, the wavelength is 10 raised power minus 11 meters, followed by X-rays. There's a range of the wavelength for X-rays. It's 10 raised power minus 11 meters to 10 raised power minus 9 meters. For ultraviolet rays, it's 10 raised power minus 9 meters to 4 times 10 raised power minus 7 meters. Visible light, 4 times 10 raised power minus 7 meters to 7 times 10 raised power minus 7 meters. Infrared, 7 times 10 raised power minus 7 meters to 10 raised power minus 4 meters. Microwaves, 10 raised power minus 4 meters to 10 raised power minus 1 meters. And radio waves, greater than 10 raised power minus 1 meters. They have the highest. Then frequency, gamma ray has the highest frequency. So it's 3 times 10 raised power 19 hertz. For X-rays, 3 times 10 raised power 17 hertz to 3 times 10 raised power 19 hertz. Ultraviolet rays, 7.5 times 10 raised power 14 hertz to 3 times 10 raised power 17 hertz. Visible light, 3 times 10 raised power 14 hertz to 7.5 times 10 raised power 14 hertz. Infrared, 3 times 10 raised power 12 hertz to 4.3 times 10 raised power 14 hertz. Microwaves, 3 times 10 raised power 9 hertz to 3 times 10 raised power 12 hertz. And radio waves, less than 3 times 10 raised power 9 hertz. Thank you.